Assalamualaikum. Today we are going to learn about the three-dimensional coordinates, or it's known as rectangular coordinates. Right, suppose usually we have the xy plane, which is two-dimensional, and usually x is vertical and y is vertical and x is horizontal. But now we put it in this way. All right, so we have the third dimension, which is z. So we have z, which is a vertical axis here, and still we call this as origin. All right, now we want to consider, all right, so in this three-dimensional space there are three important planes. All right, the first one, if we consider just only x and also y, so between x and also y we will have the xy plane, which is like this. And if we consider only x and z, so we will have the xz plane, right? And if we consider the y and also z, so we will have the yz plane. All right, so these are the three planes. Now if we have these three-dimensional axes, all right, and if we want to put a point in these coordinates, so this is the points. So usually in xy plane, right, so this is xy, we will have a point which is represented by x1 and y1, like for example. But now we will have another point which is z1. So we have this point written as P, a point with coordinate A, B and C, where A is the value on the x-axis, B is the value on the y-axis, and C is the value on the z-axis. Let's look at example 1. We need to sketch the points 0, 5, 2, 4, 0, -1 and 2, -4, 6 on these coordinate axes. Let's start with this one first. So we need to find where 0, 5, 2 is. So this is x, this is y, and this is z. So suppose we have this. Why do I have at x-axis, so it is actually 0, right? So at y-axis it's actually 5, so at z-axis it's actually 2, so it's here, all right, because this is the value of x-axis is 0 here, all right, at this point, at this point, at this point, at this point, so the value of x-axis is 0. If it is, like for example, the value of x-axis is not 0, suppose it is 5, so of course it will be this way, all right, so it's 5 here, for example, okay, something like that. So this is 5, all right, but now we want to have s is equal to 0, so this is the point, so we will have this point 0, 5, 2, right? So now let's look at the second one, which is 4, 0, -1. 4 is for the x, 0 is for y, and z is -1. So x is 4, is somewhere around here, right? 0 for y, so y is 0. So on y-axis, this is y, this is +1, +2, -1, -2. That's how you read, huh? Right, so now we will have it must be on this, all right, it's here. And when z is equal to -1, so z equal to -1, so z is positive, z is negative here, so -1, something like that. So we will have that, 4 for the, what do we call, x-axis, all right, and 0 for y-axis, and z equal to -1. So we will have the points which is here, all right, so 4, 0, -1. Alright, and we have the last one, which is 4, -2, 6. Sorry, 2, -4, 6. Alright, so 2, -4, 6. Where is it? For the x-axis, it should be 2. For the y-axis, it should be -4, and for the z-axis, it should be 6. So 2, -4, 6. Why? We have 2 here. -4 for y, so this is the value for y-axis, -4, and 6 is somewhere around here. So we will have the point which is somewhere around here. Okay, so we have 2, -4, 6. All right, before I forget, all right, because I've we have this system, all right, so this is y-axis, this is x-axis, this is z-axis. So the positive part is actually, all right, for the x-axis, this is +1, this is +2, and this is -1, this is -2. All right, for y-axis, it's positive over here, 1, 2, 3, but negative is this side, -1, -2, -3. For z-axis, all right, let me extend this one. For the positive part, it's actually up here, so 1, 2, 3, but for the negative part is over here, -1, -2, -3. All right, so that's how you plot these points. All right, if you see this, you can see that this is actually the rectangle, so that's why its name is actually rectangular coordinates. All right, now example 2, what surface can be represented by z is equal to 4. So at z is equal to 4, we note that x is equal to 0 and y is also equal to 0, so z is equal to 4 is somewhere around here. So this is z is equal to 4. So at z is equal, sorry, we didn't say, sorry, what surface represented by z is equal to 4. So we don't care what values of x and y are, so because x can be any values and y can be any real value, so at z equal to 4, z is equal to 4 over here. So right, so suppose we have like actually a plane here, right, which is this at this point. So at this point z equal to 4, at this point z equal to 4, at this point z equal to 4. We don't no matter what values of x and y are. All right, so at this point z equal to 4, at this point, any points on this plane is actually z equal to 4. So this is actually a plane which is parallel to the xy plane, because xy plane is over here. All right, so this is the xy plane. Right, now let's go to example 3. What surface is represented by x equal to 1? Where is x equal to 1? You look at this x-axis, so x equal to 1 is over here. So we have x equal to 1, which is here. So what values of y and z? We don't, no matter what values of y and z. So as long as it is x equal to 1, so we will have this plane. All right, because on this plane, all right, if you can see here, so x equal to 1, x equal to 1, x equal to 1, all right, x equal to 1, all right. So no matter what values of y and z are, so this is actually a plane which is parallel to the yz plane, right? Because the yz plane is over here, all right? So that is yz plane. Okay, now we look at example 4. Which points x, y, and z satisfy these equations? These two equations must be satisfied. So let's first look at this equation. What equation is this? It's actually a circle, because before this we learned that a circle will have x minus h squared plus y minus k squared equal to r squared, with the center hk and the radius r. So now we have this circle on the x and y, so x and y plane. So this is the plane, right? This is xy plane, so we'll have a circle here, right, on the xy plane with the center which is 0 0 and the radius is actually 2, right, because this is actually 2 square. So we'll have center 0 0 and radius 2. But at this, on the xy plane, the value of z will be equal to, right, sorry, the value of z which is equal to 0. So it does not satisfy the second equation. How to make it satisfy the second equation? We have to shift this circle, all right, shift upwards by 5 units. So we'll have somewhere around here, so that the value of z is equal to 5 here. Right, so we will have this circle actually, all right, at z equal to 5. So this is the circle, all right. Initially it was on the xy plane, but it's shifted upwards, so it will become this circle. So now it satisfies both equations. Now what if we have x squared plus y squared equal to 4, which is represented in r cube, meaning to say no matter what values of z is, all right. So suppose we have this x squared plus y squared equal to 4. So this is when z equal to 0. What about when z equal to 1? So we have to shift this when z equal to 1 somewhere around here, when z equal to 2 somewhere around here, when z equal to 3 somewhere around here, and so on. So this actually will form a cylinder, but it can also goes downward. So z equal to -1, right? So we have something like this. So when you make this, because that one is for z is integer, but z can be any real number. This is real number, so it's actually a cylinder, all right? A cylinder which is something like this, right? So this is the cylinder, all right? So this is the surface for x squared plus y squared equal to 4 in r cube, all right? Now R cube space. Let's look at example 5. Describe and sketch the surface in R cube represented by this equation. What equation is this? Do you remember y equal to negative x plus 2, y equal to mx plus c, where m is the slope, which is negative 1, and c is actually 2. So we will have a straight line with the gradient negative 1 and intercept of y, which is 2. So this is y-intercept 2 and gradient is negative 1. Now how do I make this one? Because now it does not, now on this xy plane, at this point z is equal to 0 for this line. What about if z is equal to 2? So we z is equal to 1, so we shift this line 1 unit upwards, so that is the line. What about if we shift one unit outwards again? So we have this line, we shift again, and then we'll have this line, this line, this line, so that will form. Alright, we also shift downwards by 1 unit and so on. So that's actually a plane. Alright, that's actually a plane. Alright, okay, so this we will get a plane. Alright, so we'll have this plane, okay, which is parallel to this line. Alright, now we want to find this. Let's now look at the distance between 2 points in 3-dimensional space. Suppose we have 2 points A and B with these coordinates now. So the points, alright, the distance between these 2 points, we have this one. Because in 2-dimensional space, suppose we have A x1, y1, and B x2, y2. So the distance between AB, alright, so we'll have x1 minus x2 square plus y1 minus y2 square. Alright, it's almost similar to this one, but now we have the third dimensions here. So we have z1 minus z2 square for this formula of distance in 3-dimensional space. Let's look at example how to use this formula. We need to find the distance between A and B. Firstly, write the formula. So this is x1, x2, so x1, x2. What about y1, y2? y1 minus y2. And what about z1 and z2? So z1 minus z2. So we'll have this formula. We substitute it with the value, so we simplify, we get this one. So root 44 is the distance, or can be simplified as 2 root 11. Now, we have to determine if A, B, and C lie on the straight lines, right? So what needs to be done for this type of question? We have to find the distance of AB, AC, and also BC, something like this. So we find the distance of AB, we get this one. We find the distance of BC, and we get this root 45, and we find the distance of AC, we'll have root 3. Bear in mind that, alright, suppose if A, B, and C lie on a straight line, so we'll have something like, okay, if we say that A, B, and C lie on a straight line, okay, I try my best to draw this one. Alright, so we have the points A here, A to B, and sorry, this one A to C. A to B is here. So we see that A to C is root 3 and A to B is root 26. If we find the distance of BC, this is the BC, so we should have root 45. Logically, if we see this diagram, these two distances should be the same, right? So we have the rule that if A, B, and C are on the straight line, then the sum of two shortest distance should be the same as longest distance. So this is the longest distance should be equal to the addition of these two distance. But if we find the distance between these two, it does not equal to root 45. Therefore, we cannot say that A, B, and C are on a straight line. So it is not on a straight line. Okay. Let's look at example 8 here. Find the distance of 1, -3, 7 from the xy plane and xz plane. So let's do one by one. Let's try from the xy plane. Right, so where is xy plane? Xy plane is over here. Alright. What about the points? 1, -3, 7. So 1, -3, 7 is somewhere around here. Alright? So we need to find the distance between these 2 points, between the points and the planes. Which is the shortest distance between this point to the plane? Is it this way? No, that will be quite long. What about this one? It should be a straight line. Alright? Yes, it's actually a straight line. This one, in this case, it should be a vertical. Right? Okay. So, okay, if we see here, so the distance logically, all right, so of course this one, because using Pythagoras, this one will be longer than this one. All right, so we cannot find the long distance. We have to find the shortest distance. So this is the distance, the vertical distance from the point to the plane. So what about the distance? This is actually 7 here, so 7 to 0. This is same as this, so the distance is actually modulus 7. Why I put modulus 7? Because if you have this coordinate of z, which is -7, should be the distance should be modulus positive. Let's look at this example. We find the distance between the point and also the xz plane. So plot the point first. So this is the point 1, -3, 7 just now. We want to find its distance from the xz plane. Where is xz plane? So x and z, so it should be this blue plane here. So what about the distance? So actually the shortest distance should be this way, right? So that's the, what do we call, the shortest distance between the point and the plane. So to find the distance, because it is -3 there, right? So the distance should be not -3, right? Should not be -3. You jangan terkejut kalau I tanya you, kalau I bagi tahu you tinggi I negatif 175. Negatif 175. Are you makhluk manusia or not? No. We don't have that high distance which is negative. It should be positive. That's why we have the modulus here. So we have root 3 is the distance. Okay? Let's look at example 9. Find the distance between the points and the x-axis. It's quite different. That's just now we see xy plane, but now it's x-axis, meaning to say that you have to find the distance between the points strictly to the x-axis, not the xy plane. Now we plot this point here. This is the point. What about the distance between this point and x-axis? It should be measured. All right. It can be this way, it can be this way, as long as it goes to the x-axis. But which one is the shortest distance? So to find the shortest distance, all right, okay, you should not measure this way. Just now, yes, because it is, we measure the point to the xy plane, but now it's not xy plane. We don't want to measure between this point and this point. This point is not on the x-axis, so we have to find the distance between this point and these 2 points. So we will have to find this point. What point is it? It's actually 1, 0, 0. How do I know this? Because this is 1. So 1 on the x-axis, of course, y and z should be 0. Now we have to find the distance between these using Pythagoras theorem. So we know that 1, 0, 0 is the point on the x-axis, which is shortest to the point. Therefore, we can find the distance between the 2 points using the formula. You get root 58. So you know, alternatively you can use this, what we call this one, Pythagoras theorem. Okay, using this triangle. This is the triangle here. Okay, I bring this triangle to this one. All right, now let's look at the concept of midpoint. In two-dimensional space, suppose we have A, which is x1, y1, and B, which is x2, y2. To find the midpoint between these two, so this is the M, we will use the formula x1 plus x2 divided by 2 plus, comma y1 plus y2 divided by 2. This is the formula for the midpoint. But now we have the z-axis, the z coordinates. So of course we will have this formula. We just add to this coordinate. All right, so we have this formula for these midpoints between 2 points in three-dimensional space. Let's try to use an example. We need to find the midpoints between these 2 points. So this is the formula. All right, so you have to identify which one is x1, x2. So this is x1, this is x2. You add them together, divided by 2. y1, y2 will be this point and this point. what about z1 and z2? So you have this one and this one. So now you substitute the values inside the formula. You will have this and you have this. Simplifying this, 0 divided by 2 you get 0, 6 divided by 2 you get 3, and 11 divided by 2 you get 5.5. So this is the point, the midpoint between A and B. Now, another important concept in three-dimensional space is a sphere, because usually in the xy axis we will have the equation of the circle, right? Suppose we have this circle, right? I write this circle here. So this is hash k, the center hash k, and the radius is actually r. We will have the formula for the circle, x minus h square plus y minus k square equal to r square. But now the same thing in three-dimensional space for the sphere. So we have the third dimension we have to add here. So in this case, suppose we have the center ABC and radius r for the sphere. So this is the part where we add here, z minus c square, all right? So equal to r square. This one is the radius, okay? So this is the formula for the sphere in three-dimensional space. Next, let's look at this as example 11 here. Find the equation of the sphere with the center and radius 4. How to do this? We have this formula. This is the center, A, B, and C. We insert into these values, all right? So we get this with the radius 4. You simplify this one, all right? You get x plus 3 square plus y minus 2 square plus z minus 5 square, which is equal to 16, all right? 4 square equal to 16. This is the equation of the sphere with the center negative 3, 2, 5, and radius 4. Let's look at example 12. We need to find the equation of the sphere with center 2, negative 6, 4 with radius 5. So firstly, we find the equation of the sphere. So using the formula, we substitute the values of A, B, and C here. This is A, B, and C. So we get this formula. So this is the formula for the sphere. But describe its intersection with xy, xz, and yz plane. So we do one by one. We start with xy plane first. Suppose we want to intersect the sphere with the xy plane. We know that xy plane, this value of z should be 0. Alright? Recall, if we have this is y, this is x, so this is z. This is the xy plane, therefore the value of z here should be 0. So now, we substitute the value of z here 0, you get this one. Simplifying, you get this. What equation is this? Recall that this is the equation of the circle in the xy plane. Now do we have the circle with the in the xy plane, but the center is actually 2, negative 6, 0, because z is actually 0 with the radius which is 3. What about the intersection of the sphere with the xz plane? Let's look at the xz plane. At xz plane, the value of y should be 0. We substitute the value of y here with 0, and then we get this formula. Simplifying, we get this. If you observe this equation, there's something wrong with this equation. Why? Something square with something square, you'll get the negative number? Never. Because the sum of two squares should be positive. At least 0. At least 0, 1, 2, and so on. Alright, it should be positive because this number is square, this number is square. If you add these two squares, it should be positive number, but now it's negative. Therefore, there are no points which satisfy this equation. We can't say anything, we can't conclude anything. Now, for the part where we want to find the intersection with the yz plane, so we have the x equal to 0. We substitute the value of x, which is 0 now, so we will have this equation. Simplifying this, all right, simplify, you get this one. What equation is this? Again, it is a circle in the yz plane. So the circle in the yz plane with the center 0, negative 6, 4. Why 0? Because x is 0. 0, negative 6, 4 with the radius. So this is actually, we should take square root, so you get square root 21. So this is example 12. Let's move to example 13. We need to find the equation of the sphere passing through 4 3, -1 with the center 3, 8, 1. This is the center. So we have the center using the formula. This is A, B, and C. You get this one. Do you know the radius now? We don't know the radius. But since this sphere passed through these points, so we can substitute the value of x with 4, y with 3, and z is equal to -1 to get the value of r square. So we substitute these values inside this formula, x, y, and z. Then you'll get the value of r square, which is given by 30. Now, because you need to find the equation of the sphere, read by the equation of the sphere. So this is the equation of the sphere. This part only should be substituted with 30. So we will have this equation. We are done. Easy, right? And finally, we have example 14 here. We need to show that this equation is a sphere. How to show this? Meaning to say that we have to show that it is in the form of x minus a square plus y minus b square plus z minus c square equal to radius square. How to do this? We need to write this in general form. How? We need to bring, okay, suppose we have this one. So I want to make, because you can see that the coefficient of x square, y square, and z square are all 2, so I want to divide each term in this equation with 2. So I have this, meaning to say I divide this with 2, divide this with 2, divide this with 2, so we'll get this one. Now I want to bring all these terms on the right side to the left side, so we'll have this one. All right. I bring this one first. Okay, I bring it to the left side. So now I want to make it completing the square, meaning to say that how to write this so that I can get the x minus something square. That's what I mean. So you have to add 4 for this one. Why? Because okay, this one you have to add 4 because, right? Because x minus 2 square, you expand this one, you get this expression. For the z square, you have to add 36. When you add 4 and 36 on the left side, you have to add 4 and 36 on the right side, so that the equation will be equilibrium. Now you can factorize it, so you can write x minus 2 square. Y, we don't have any other term, so we have y minus 0 square and z plus 6 square, so this part will be 81/2. So this is the equation of the sphere with the center 2, 0, -6, and radius is the square root of this one. We'll get this value. That's it. Thank you for watching.